So we're talking about public and private keys and using SSH, and I thought I'd take a minute just to talk about encryption and how HTTPS works at a rudimentary level. And so here's a really simple cipher system called ROT13, Rotate 13. And it's also known as a Caesar cipher. And so if I sent you the message, and this would be, there's symmetric and asymmetric keys. And symmetric keys means that the same key is used to encrypt and decrypt. Okay? Same key is used to encrypt and decrypt. And so I have some key. The key is to rotate each letter of my message 13 characters in the alphabet. I send you the encrypted message. You have the exact same key. Symmetric keys, same key. And you rotate things 13 to decrypt. Right? And so if I sent you the message of ZR, if I sent you the message ZR, okay, so follow me here, ZR, U, R, Y, and C. So ZR, U, R, Y, and C. Right? I sent you an encrypted message. That message here, let's just do it up here. ZR, and then U, and then R, and then Y, and then C. Right? So that's the encryption I send you. ZR, URYC. And then you get that message, and we're using symmetric keys. I rotated at 13 to encrypt it. You would rotate at 13 to decrypt it, symmetric keys, and you would translate the Z to be a what? What's Z rotated 13? M. What's R rotated 13? E. What's U rotated 13? H. And what's R rotated 13? E. And what is Y rotated 13? L. And what's Y is L, right? And then what's C rotated 13? P, right? So that's a simple Caesar cipher using symmetric keys. Okay. So with public-private key, that's asymmetric keys. And so I have a private key, and then I could give a public key to anybody in the world. It doesn't matter. And with that public key, people can encrypt things, encrypt messages, and send them to me. And I could decrypt them. Nobody else could decrypt them. You could only decrypt with the private key. Okay, so people encrypt with the public key, they send me a message, and then I decrypt with the private key. Once it's encrypted, nobody else can unlock it. The public key can't unlock it, because I gave that to everybody. And so if John encrypts something, and then sends it to me with the public key, and John encrypts it with the public key, and then Jane intercepts it, and with the public key tries to decrypt it, she can't. Okay, only the private key can decrypt it. And so that's asymmetric keys, and so that's how we could establish secure communication. I could give everybody in the world the public key. Anybody could use it. Anybody could see it. And then they encrypt stuff and they send it to me, and I could decrypt it. And do you know what I could do when I decrypt it? I could then take whatever was sent to me, because somebody out there could then send me a unique key. They could generate a unique key. Right? And they can encrypt it with my public key. It is now secure. Nobody else could see it except me. They send it to me over open communication networks. Nobody could understand what it is. I get it. And I take that message, which was encrypted with asymmetric encryption, which is I hold the private key. I give it the public key to everybody else. I decrypt that message. And what was that message that somebody sent me? What did they send me? So what somebody could send me is a symmetric key, and now with a symmetric key, right? It's the code that we agree on. It's the method that we agree on for encryption, and now that key will both encrypt and decrypt. So we now both have a key which allows us to do symmetric encryption, symmetric key, and that key, right? With that key, I can encrypt a message and send it to that person. Nobody else has this key. And they could receive it and decrypt it, understand it, respond, encrypt the response, send it back to me, and I could uncrypt it, decrypt it, right? So that's just back and forth with symmetric keys. So symmetric keys enable the back and forth. So that's kind of cool. So that's just like, and I'll diagram this on the board so you can see it visually a little bit more, but that's how asymmetric versus symmetric keys, and public-private is asymmetric, they're different, and then you get symmetric keys, we could do this back and forth communication securely. But we use public-private to establish, you know, the transference of a key which will allow just you and I to communicate, and that key would be symmetric. Could we use public-private just for you and I to communicate securely? Would that work? Right? How would that work? Okay, you've got my public key, you encrypt, hey Todd, what's going on? I receive it, I have my private key, I decrypt it, I read, hey Todd, what's going on? I want to respond, nothing much, how are you? If I encrypt it with my private key and send it out there, and if the public keys could decrypt it, anybody with a public key could intercept that and decrypt it, right? So that's not secure. And so what we need to do is agree upon some sort of method for having secure communication. We need keys that only you and I have. But how do you transfer that key to me without anybody else being able to decrypt it? Use my public key. And I'm the only one that could decrypt it with the private key. I'm the only one that has the private key. Do you get it?
I do. It was just like, I was following you, I was like, oh God, where's this going?
Isn't that cool? What's up?
So you were saying send the symmetrical key over the public key?
Yeah, so you would, you know, maybe we say ROT 7, but if you say that out loud, everybody's going to know it. Right? Ah, they're using ROT 7. Now I can intercept their messages and understand them. So instead, you need to communicate with me in a secure method to tell me ROT 7. So I create asymmetric keys. I hold the private key. I give anybody in the world the public key. That allows people out there to encrypt stuff and send it to me. And if they encrypt it and send it to me, nobody else can unlock it, only me. So you encrypt, Todd, we're using ROT 7 with my public key. You send it over open communication. Nobody else can see that. It gets to me. I can unlock that, right?
If you send it over public key, then how come no one can see it?
What do you mean?
You just said you send it over public key. And
You encrypt it with the public key that I've given to anybody in the world.
But if it's the public key, how does nobody able to decrypt it?
It only encrypts.
Okay. So the
Public key only
It
encrypts.
will only encrypt on decryption.
Okay.
Yeah.
All right.
And so it encrypts, sends it to me, it's secure. And I open it and I see, hey, Todd, let's communicate with ROT 7. I'm like, all right, cool. And then we have now a private encryption symmetric key which encrypts and decrypts. And we could do, you know, communication. Now I could encrypt something with that, send it to you. Nobody else knows that key. Nobody else could decrypt it. You get it, you could decrypt it. Then you could re-encrypt, send something to me. Nobody else could get it. Now we're secure. Isn't that cool?
Yeah.
That's pretty cool.